Hi friends, welcome back. Now let us see the key steps involved in a machine learning project, what exactly we have to do when we are building a machine learning project. So let's see what are the steps to follow. So the first step is to collect the data. Data is the foundation of any machine learning system. So the first step in any machine learning project is to collect the data. So the data may be collected in various ways. It can be collected through forms and questionnaires, maybe through conducting interviews, or maybe by observation, or from the documents and the records we can collect it, or we can collect it from oral histories, can be collected from combination research, online tracking, online marketing analysis, social media monitoring and all that. So there are many ways of collecting it. So basically there are two ways of collecting data, or two types of data we can say, to be exact. One is called the primary data, other one is called the secondary data. The primary data is the one which we collect ourselves for our project. So that is whatever data we require for our project, or to solve our problem, whatever data we require, if we collect ourselves, then it forms a primary data. That means it's a data that is perfectly suited for our purpose. So exactly what we want, we keep searching all around and collect that, and that's a primary data. And advantage is what exactly you want is available with that. But the other side of drawback is that it is costly, it is time consuming, and a lot of resources are required and all that. So it's time consuming, and we should have a proper plan to collect the data and all that. So that's one side. On the other side, we have secondary data, where someone else has collected data for their purpose, and if that data can serve our purpose, then we can borrow that data from them and use it. So yes, that is secondary data. We don't have to run around for collecting the data. Somebody else has already done that, taken pains to collect the data and put them in one place. So we just have to borrow from them, maybe with a fees, or freely and all that, depending on from whom we are borrowing and all that. Whatever it is, yes, availability of the data is very easy. But the only problem with that data is it may not be tailor-made to our problem. So it is the data they have collected to solve their problem. So it may not be totally convenient to use as it is, as per our requirement. So we need to modify or tailor-make to our requirements. So that is what secondary data is. Whatever it is, so we have to first collect the data. That is the first step we have to take up. And once the data is collected, we are not sure that the data is in proper form, proper shape and all that. Some data may be missing, some data may have error, some data may be out of the range, and something maybe different types of errors and all that. So we need to make sure that our data is clean. So we have to clean the data, then check that the data is within the range. So usually we normalize each input so that it is within the range. So the different inputs are of same range, so that they don't what is supersede the presence of other one and all that. So if one input is in one tens and all that, and if another input is in thousands and all that, so the variation in thousands can hide this variation in ones and twos of another input. So the variation, the parameter which is varying in terms of thousands, may not allow the variation or the parameter which is varying in ones or tens to be visible in the overall global scenario. So to make sure that each one is equally visible, we need to normalize them. So sometimes the direct data may not be useful, so we need to modify the data. We want to transform it to another form so that it becomes easier for us to use the data, to work with the data and all that. So some features we need to extract from the data, for feature engineering is required. And some cases the data may not be in balance. That means when you are talking about classification type of problem, then one class, the data belonging to one class may be in very large number, and other data belonging to another class may be of very small size, and this imbalance in the size will definitely will not allow the balanced machine to be created. So there will be a bias, and this bias has to be removed. So to make sure that such bias doesn't exist, so we need to ensure that there is no imbalance in the data. Somehow try to balance the data, either reduce the number of data which you are having more in number, or somehow try to increase the number of data of the class where the number were fewer in the beginning and all that. So that's what we need to do before actually getting into work. So make sure that the data is perfectly all right, only then get to the next step. The next step is to create a model, choose a model. So this model can be a decision tree or neural network, support vector machine, and many more. So just looking at the type of the data we have. So does the data has got any response? If yes, then we are talking about something like supervised learning, that is input output both are there. So the input is there and its response is also there, then input output both are there, and then we are talking about supervised learning. And in supervised learning, if the predicting value is a numeric one, then we are working with regression, or if it is a categorical, then we are working with the classification. On the other side, if we don't have any response, then we are working with unsupervised learning, and this unsupervised learning again will be either clustering or dimensionality reduction. So just look at, are you looking for dimensionality reduction? If yes, then go for dimensionality reduction type of unsupervised learning. Otherwise you just go for clustering. So that's what is to be done. Next is to choose an appropriate model depending on the type of data we have and type of the response we are expecting from our model. And once that is done, then this model should be trained with available data, and this training is done through feeding the training data to our model, so that our model can learn the patterns hidden in the data, and this learning of the pattern is what we call training the model. And once the model is trained, then we need to verify whether the training is successful or not. So we need to evaluate the performance of the model. So test with some unforeseen data, and then look for accuracy, precision, recall, F1 score, etc. So it can be done through what we call a confusion matrix, which is shown here. So that confusion matrix can be used for computing the accuracy, precision, recall, and finally precision and recall together can be used to calculate the F score. So this evaluation performance is done, and once we are happy with the performance of this model we have created, then what else? Just deploy it. So deploy it and start using in the real world applications, and keep refining it. So use it, give new inputs, check the output, and these input output combinations you feedback, check the performance, evaluate the performance of this newly generated outputs, and see how better your model is performing. If you find that the model performance is deteriorating, then we need to refine the model, retrain the model, add new inputs to the data set, and then again retrain it and all that. So these are the key steps involved in machine learning project. So let me recall that. So collect the data, then pre-process the data, then choose a model, train the model, evaluate the performance of the model, and finally deploy it and use it. So that's it about the machine learning project steps involved. So this is Sandeep signing off for this session. Thank you.